Let's start doing this program.
Shiva, I attend today morning class.
Who is this? What is your name?
Hello. Yeah, Venkatesh.
Oh, okay. I didn't see you. Your name was not displayed. Okay. Yeah, just try to join 1 minute early so that I don't need to come back and update it again. Okay. Uh,
I attend all your session, but on 5th it says absent. I don't know why.
15th also you attended? Yesterday morning you attended? Oh, I gave it to Teja actually. Sorry. Yeah, I'll take it to Teja's. Okay, that is okay. Don't focus on this much. This is just for tracking for me and the consultancy. Oh, come on, voice just problem. Hey guys, yeah, looks like we are facing some voice issue. But it's okay. We will try to continue as much as we can today class. I should have thought like it's a Friday, right? So a lot of consumption will be there, data consumption. So it's a little um, continue as much as we can so that we can wrap threads today. Okay, nice. So I was trying to run one program. Let me finish my practice program. Okay, I want to see the result. Nice, achieved. Okay, so this is the class. This is what you're talking about. 15, 16. 16 new class concepts. Okay, so in the last class we discussed about like how we are handling thread scenarios, like if you keep one thread in sleep, then the remaining threads will continue to run. So basically my goal here is like to show you how multiple tasks. Ideally, when you have this kind of setup, first thread will, if there is no threads, right, what happens? Let's assume you haven't extended this class. Okay, you haven't extended class, there is no run method, you do explicitly this program, okay, by calling here like m1, and by calling m1 here, and without extending this class, what happens? Simply I'll show you. Okay, these set name get names are little annoying, so you can write your own setters and getters. What we can say is like here string name, and what I will do, I'll write a constructor, my thread constructor. I hope you guys remember in the morning program, all I'm trying to do is what happens if there is no thread concept at all. What happens in this program when there is no thread at all? Okay. Oh, my voice is breaking. Oh man, that's the problem with internet connection. It connected to guest. Why? Give me a second, let me try. Where is my network? Can you able to hear by any chance? Can one of you confirm? Okay, yeah. Ritesh, if you think voice is breaking, what you can do is like dialing from your phone and listen to look at the video. That would be the easiest. I mean, I can suggest you for now. Okay, if it happens again for me also, I will try that as well. Okay, thanks. So what I'm trying to do is, what if there is no thread concept for this program? Okay. So somebody passes name and this dot name we have a constructor already, right? What I'm trying to do, just copy this line. Instead of this line, setter set getters concept. Just there's so many distractions right today. And then here I'll just say, instead of my name, I'll just say name. Okay, this program works fine. And here also, instead of this guy, I'll say name. Okay, this is my typical program, right? So there is no thread sleep. Okay, let's say. So let's say this line is not at all there. We are doing nothing right here. We just do sleeping the thread. So without sleeping the thread, without pushing the thread into the sleep state, what we're going to do is we just say removing that. So all we're doing is we have a simple class where you have a static and you have a constructor which will take an argument based constructor. It will take some name and you are assigning that name to the local variable, and then you are calling this method, and this method you're just looping something and displaying that name. So in this typical program, what will happen, this will be get called. So this constructor will be get called. In the constructor, this method will be get called. This method is nothing but M1 method. It will loop everything. After finishing for Java, then it will go to T2 Scala, and it go to what you call Node.js. It goes to Angular, right? Done. So let's me run this program. What happens? If you look at here, so what happens? First Java called all the way. It looped for 10 times. Then it called Scala. It looped for 10 times, and Node.js, and then Angular. If you observe here, what is this number? This is the X number, right? And for Java, it started with 100. For Scala, it is 110. Instead of starting with 100, for Scala, it started with 110 because you have a static variable. If you don't have a static variable, let's say this one also not there. Okay, what will happen? Now, if you come here, for Java 100 to 109, Scala 100 to 109, Node.js 100 to 109, AngularJS 100. So these are 4 different objects that you try to create, and each one will take its own value starting with 99. But as and when you define a static, that particular variable, that particular member will be shared across different objects, T1, T2, T3, right? That is the reason when you ran, you got in a sequential order and up to 139 the X value has been keep on incrementing even though for different objects. That is good. But if you observe, another good thing is they are happening in sequential. Until and unless this Java's concept finished, it doesn't go for the Scala thread. Until and unless Scala thread finished, it doesn't go for Node.js. Until and unless Node.js finished, it doesn't go for Angular, right? But in the case of thread concept, right? So I'm going back everything, I'm reverting, okay, into thread concept now. Okay, now everything is as is, right? I've just comment this piece like the way we did in the earlier class. Okay, now run the program. What happens? Now see, it started with Scala, it's then Java, Scala, Java, .NET. If you go, come down below Scala, right? It's like jumbling. The program is getting jumbling, right? It's not consistent, it's not sequential, and the total value of the value, end of the value, if you look at, right, end of the value is, there is no Angular displayed at all. Oh, we haven't changed, I guess. Node.js Angular. Now see, Java, Scala, Angular, Java, continuously running Scala, again Angular, Scala for some time running. So what happens by introducing thread concept, you are utilizing the best of the best from the CPU or the JVM from the by using the threads. Most efficiency you are getting. Okay, most efficiency we are getting. So that is the advantage of threads concept. That is awesome. But if you look at the values, Java started with 1, Scala started with 101, Angular 103, then Java comes 102, then 105 it moved somewhere, Java 106 came, right? If you try to see, so much jumbling, right? So how do you address this? So what I'm trying to say is your X value here, X static value is getting dirty. Instead of properly getting updated this X value, it is getting dirty because everybody is trying to update. What happening is in this threads concept, let me show you, okay? You created 4 threads, right? From 4 objects, 4 thread objects, right? 1, 2, 3, 4. T1, Java 1, Java, this one is Scala, Node.js, Angular. So 4 threads are 4 worker threads are created, and you have one value called x equal to 99. Okay. In a sequential concept, what happened? Java will be called and keep incrementing Java x value, and it becomes 109. Nobody is touching it. Then Scala enters, it increases from 109 to 111, whatever the value. Then Node.js enters, it becomes 120 something. Angular enters, it becomes 129 or 139, whatever the value supposed to increment, it reaches correctly. But in case of x equal to 99, right? Java, Scala, Node.js, and Angular. In case of threads, what we're trying to say is, okay, you Java get called. Okay, something is there. I mean, by doing some operation, while doing this operation, JVM takes a fraction of milliseconds it will take, right? In that time, the thread is sitting idle, right? Incrementing is like it need to x plus plus this is one operation, right? Imagine this is x from x to x plus plus you are asking to do the for Java. So when it is doing this operation, incrementing is like it need to go and it need to find the location of the x and move from 99 to 100, and it needs to find the 100 is like 1 0 1 0 1 0, some logic need to be applied and identify and update. It takes for fraction of millisecond, right? In that fraction of millisecond, this thread is sitting ideal, this thread is sitting ideal, right? So what happens then? CPU immediately provides the Scala to, okay, threads are ideal, go, you go up. You know, that guy is busy, so you go and start processing. Same thing happens for Scala. And while this guy is updating, Node.js also came. So Scala also updates from 100, Java updated, let's say, properly with 100. Then Scala came, and at the same time Node.js also came. Both try to update this. Okay, both try to update this value from 100 to 101. So instead of 101, 102, if third thread, if like let's say 1, 2, 3, third thread, if third thread is executing, it should be, instead of 102, it became 101. Because both try to update the same value, someone's value is got overridden. Someone's value got overridden. Okay, so in the logs you will see 101, Node.js 101. And when it comes to here, it says like 103 or 104 because Java again tries to update. So the data is getting dirty. There are some situations where you don't want your data getting dirty. So what are those situations? Let me show you. Okay, let me tell you. I am going to remove this static. Okay, this no harm done for this program, no harm done, because each one will have, see, if we look at, even though they are running differently, each one Java ending with Java 109 and where is that, Angular is ending with 109 and Node.js is ending with 109. Everybody is ending with correct values because in this case what happened is each one is having its own X value, right? Instead of shareable value, each one is having its own value. So threads are very, very powerful when you are playing with your own data and when you are not playing with others' data, or when you are not playing with the shared data. So powerful, and it gives you so efficient results. But you need to be very, very cautious when you are working with shared data. Okay, to show that example, I take the concept of static, because in static is shared concept, right? So it's a simple way I can show, I try to explain you. Okay, now how do, so you cannot say like, okay, if there is a shared data, threads cannot work. That's kind of a bullshit statement, right? Like, you know, then what is the point in creating the threads concept, right? In every application there will be some shared data. It doesn't mean that, let's say you have 100 files and you are using like a 10 and it's a simple understanding wise I'm saying, it's not really like that. Okay, there are 100 files and there are 3 files where the important data information should be shared between different files, okay, let's say, and remaining 80 files are like free, you can play around. So in this kind of applications, if you say, oh, there is a shared data in 3 files, so you cannot use threads, right? It's a crap, it doesn't work like that. So threads concept should have a solution for this concept as well. Threads concept should have a solution for handling the shared data as well. Okay, how does it do? Give me 1 second. Yeah, using the concept called synchronization, threads will be supported for the shared data as well. Okay, so basically, and another problem is not only that, there are different problems. Another problem is there is a kind of a deadlock, right? deadlocks also will be there. What is a deadlock? What is a deadlock? Deadlock is something, let's say, another thread problem is like, let's say, it's maybe you learned in your engineering or anywhere, right? Like in your masters or somewhere, if you're doing computer science, like say, like you have a resource 1, you have a resource 2, two resources, like, you know, XLS file, database. Okay. And you created 2 threads, T1, T2. Okay. T1 concept is access this guy XLS file 1, access XLS, okay, hold of it and access database and update them. That is the T1 concept. T2 concept is access database, then access XLS and update the both files. So what does mean? It is working on this one and this guy is also working on this one. At the same time, it required this one as well. For this, it required this one. This is nothing but a deadlock, right? A thread is like, you know, thread T1 which is holding a resource R1 is waiting for the resource R2, and thread T2 which is holding resource R2 is waiting for resource R1. This is nothing but deadlock. So T1 releases the resource R1 getting R2 resource, and T2 releases the R2 getting release of R1. So this never going to happen, right? They won't release the resources and they won't get the resources also. Simply the T1 and T2 goes into the blocked state, right? There is no chance, like, you know, they're never getting released because someone is holding something and expecting something, and the same guy holding other part which he is expecting, and it's never gonna work, right? This is nothing but a thread lock. Okay. And now, just for the sake of concept, I explained this. Synchronization. Okay. So synchronization, why you need in synchronization? Synchronization in multi-threading environment, the one that we are doing currently in multi-threading environment, when all the threads are accessing the object, any particular object, in our case static data, static variable, let's assume that object kind of object level is trying to access concurrently, the data will get inconsistent. The data inside the objects will get inconsistent. In our case, static variable get inconsistent, right? The data instead of having the proper static value, you are seeing different values, right? What you can do in those concepts, what you can do, all you need to do is, even though you are using threads, when there is a shared data, when you think the data will get corrupted, data will get dirty, then all you need to do is allow one guy at a time. So in multi-threading environment, whoever gets the free, whoever gets the priority, whoever gets free CPU, whoever gets like a time, they're just going and playing with the data, right? As long as the data is not consistent, not shared, as long as the data is secured within the thread, not going to access by other thread, then that's going to be perfectly fine. But in the concept of shared data, they are going to create troublesome and with inconsistent data. So all you need to do is, if there is a shared data, something like this, if somebody comes in, let's say T1, try to access this data, let him enter, start working on it, and let him have complete control on that object. That is nothing but lock, complete control on that object. And if somebody comes while he is doing it, if some T2 comes to update that, say that, okay, I got locked by T1, until T1 releases, I cannot give you an access. That is nothing but a synchronization. That is nothing but a synchronization. Okay, so that is nothing but to avoid these inconsistent results, I don't want to allow all the threads to access the object concurrently. I want to allow one by one to access the objects. This is simply known as synchronization. Got it? So they use another word also, monitoring. Like, there is a logic. You want to all threads try to access. So let's say if T1 try to access, T1 is accessing this data, immediately monitoring will established around that thread, that object, and until and unless this T1 finishes this function, T2, whatever the threads that comes into, they won't get access. Okay, once he is done, T1 is done, while he is coming out, he will say release lock, and then he will come out. Then what happens? This object becomes free again. One of them will be entered again and modify it and come back. In this way, you will get the consistent results. Okay. So in those lines, when you synchronize this object, object will be locked and will be monitored. Okay. How do we do? Now this is the concept, right? Next thing is, how do we do in Java? How do we achieve it? How do we achieve it? So where do you write the logic in Java? Most of the logic goes where? In your class, where it goes? Into methods, right? The logic, most of your logic, all the initializations or creations will happen outside the methods, but inside method, the core logic, the business logic will be getting executed, right? So you can achieve this synchronization in two ways: by applying the keyword called synchronization at method level or block level. Okay. Synchronization is not allowed for what you called class level or interfaces. You cannot apply to interfaces, you cannot apply to classes, you cannot apply to variables. You can only apply to methods and blocks. Okay, let's see how do we turn this example, right? I'll take everything as is, just to keep the program as is. I'll just take this guy. I'll keep it here but it will cry, I believe. Oh, different package, right? It's okay, good. Here what we will do, we'll do the same thing, nothing fancy. Now see the difference. Okay, but one thing we need to do, right? You need to apply method level synchronization or block level synchronization. So one is method level. This is where you want to logic, right? This is the value you want to protect it. This is the value you most worried about it, because that is the static variable. So this is the static variable which is getting inconsistent across. So you want to use this variable, you want to protect this variable. So either you can make this method synchronized, or make this block synchronized. I'll show you how. First, let's synchronize this method. Synchronized, that's it. All you need to do is synchronized. Using synchronized, you can protect shared data and you can avoid getting dirty data. Okay, so by doing this, so where do you use keyword? So these two will always be next to each other, return type and method name. So if these synchronized or public synchronized, public or static, all this can be you can move around, doesn't matter. Okay, so let's run this program. What happens? Now you can see the results in consistent way. Okay, so what happened when Java entered until it finishes? Okay, this block, because you lock for Java thread, it got this block, this object, this class got locked with Java object T1. So with Java object, this class got locked and it's keep continue running it. Okay, same thing with Angular, Scala, and same thing with Angular. So as and when they enter the thread, they will get locked, and until they finish, they are not coming out. Okay, this is one way. Other way of doing is, let me show you. Synchronized this. I mean, I'll do one more example. Don't expect sequence. Don't expect sequential. The only is, all you can do is protecting the data and not getting dirty. Because they are threads, still they can jump around. I'll show you another example. I'll show you this, because we are doing inside the run methods, right? Now which blocked? Okay, so Scala 101 and Java is getting dirty. I should not get dirty because it didn't get the control completely. Give me 1 second. Something wrong. Share. $99. What I will do, I'll just synchronize this guy. But this complete object will get locked actually on that particular thing. Next one is without synchronizing. We will see here y++, and I will move this guy inside. As and when incremented, you display it, and I'll move this guy here as and when deployed. But you want to see the difference, right? So y equal to, the y is not synchronized, x is synchronized, right? X is protected, y is not protected. Okay. Did we put something? Let's run this first. Oh. What is synchronized? X is synchronized, right? X values, if you take out from here, see, give me 1 second, huh? I'll just show you. See why. Take out X. Oh, damn. Let's teach that. So AngularJS, these are Node.js, AngularJS, Scala, Java, X, 137, 136, 135, 134, 132. Right jump, right? Okay. If you run multiple times, you can see, I believe. Let me try. It may happen, it may not happen, right? Ah, this is a good example, I can see. Because data getting dirty is not always right. Right, each time if everyone is getting same time, then they won't get dirty. So if you look at here, right, so Y is not synchronized, Y is not protected, X is protected. If you look at Y, it's the stop itself, same value, it never happens, right? Same value, it never happens. Let's see for X case, X1, not 2, 1, not 3, you don't, not 4, 1, not 5, 1, not 6, 1, not 7, 1, not 7, 108, 109, 100, 111, 110. So if you look at, right, at least all I'm trying to say is X is not duplicated. The value is not getting overridden by someone else. Consistently it is 1 to and 101 to 139. But here Java and Scala got, like, got same value. So that is where I'm saying this value is got protected. This value is not protected. Because same time Java and Scala try to update this guy, nobody is protecting this guy, so they update with the same value. But for X, if Java is updating it, Scala doesn't able to enter into it and are able to enter this pass. Got it? And sometimes you may not feel the difference because the data will get inconsistent in a scenarios when the particular scenario should happen. You got it? Somebody asked question, right? Yeah, Ritesh, did you understand? Okay, cool. So let's do another example. Okay, that is the last example for threads. I would like to do one more, but let's see. I'll quickly run the program. Okay, I practiced already, so I can save some time. Synchronize, right? Synchronized demo. So what I will do, I will create a class called increment. Okay, class increment inc, simple. Okay, in this increment class I will have one static variable. Okay, static int a assigned to 0. Okay, and then one simple method, nothing, simple method will be there, public void count. counter, whatever you want. Okay, so here somebody will pass this method a name. Okay, SYSOUT. All I will do is counter and name of the thread, name plus count plus a plus plus. Just display that name. Okay, nothing more than that. Just whatever the name passed and increment this value each time. But to increment this value, I need to go for loop. Okay, for int I assigned to 0, I less than 5, I plus plus. Okay, I'll just keep this guy inside. So all this method is do. Okay, this class will do, this method is will do. Okay, and then I'll create this class objects, 2 objects. Okay, just 2 counters. I am creating 2 counters, 2 increment methods, increment classes. inc c1 equal to new inc, that's it. And another one is inc c2 equal to new inc. 2 counters I created. Okay, now forget about this. Next, create a class called where you actually going to do all the logic, business logic. Okay, let's assume we can call it as dirty protector. You can call it as dirty protector class. So if you want to make a threads concept, what you need to do first and foremost thing, implements or extends, implements runnable. Okay, so yeah, implements runnable or extends thread, right? So earlier program I did for run a thread, what you call it, extends thread. Now I'm going for implements runnable. So as and when you go for interface, it will ask for implement the default methods. Okay, now what we can do is I will take one inc object here, dummy object. I assume some main class will pass to me, and I need to create a thread t because this is to pass it, because this run method I cannot, as I am not extending thread class which have a bunch of methods which I can use it, but here I am implementing runnable. I have only run method, remaining things I need to get for thread class method. So I am creating thread object. Okay, and then what I will do is I'll create one dirty protector constructor. Okay, this is the one where I'm getting initialized with all the values, right? What and all I will give it is, one is string, whatever the thread name, comma, and inc counter, whatever the counter. Okay, counter I. Okay, counter inc, just okay. Then what you can do, you can initialize these values with this thread names, all the blah 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 stuff, right? So what I will do, inc this dot inc equal to inc passed by, and t dot set name, whatever the name that has been passed by. So I can use anywhere. Now the value has been set here for this thread. I can use here, I get off thread, right? So I can do that. And but you need to create that thread. This is a null thread, right? Now you have just a reference variable. You need to create a thread first, right? T equal to, otherwise it will throw what? Null pointer exception. because you haven't created an object, right? New thread of this class, current class, with thread name. Okay, so this is what we do in the constructor, and the in main method, this is where our business logic and we want to see the differences. Okay, I will do simply as and when it is getting called. One more thing we forgot, I'll tell you. Thread started. Okay, which thread started? I'll just t dot get name. I set the value already, right? Get name it will give, and here what I will do, I'll call this guy inc method increment. Okay, inc I initialized, right? This one got initialized, this inc got initialized by passing value of inc, and so now that particular object, whatever it is, inc dot counter and whatever the t dot get name. Perfect. And then what we will do here, again system dot out dot println program thread ended. Okay, what is the thread name? Ended thread name, because that is what you are trying to see the difference, right? Okay, so this is regular method, right? Let's run this one. And the main method. Now go back to the main method. Here what you need to do, I'm going to create a dirty protector, d1 equal to or else core dirty protector. Okay, core dirty protector, whatever the reference name I can give, right? New dirty protector of, you need to pass something. What, and its constructor is expecting something, right? Otherwise you need to write default constructor and you need to initialize, but we need to initialize for sure. So core constructor is, this is core Java, and I'll pass this increment, c1 increment. Okay, you see what I'm trying to say? So c1 object, static variable, and I'm passing that object to this dirty protector constructor. Okay, don't get confused. And then again dirty protector, let's copy this guy, and you want to see the difference, right? So you need to have at least two. Advanced, we call it as advanced, and I'll pass the another c2 counter. Okay, that's it. I'll run this program. What happens, this program, when you run, these two objects will be created, just objects will be created, and you are passing those objects to dirty protector class and core Java. And so when it goes here, this core Java will be initialized for the thread name, and inc counter 1 is initialized here. And then what happens, you just run this program. So to run this program, what you need to do, t dot explicitly start, otherwise it doesn't trigger, right? So now it start will trigger run system dot thread name, it name will be displayed, and then inc dot counter, this method will be triggered. When this method will trigger with the name core Java, it loops 5 times, and core Java will be core Java 1, core Java 2, core Java 3, core Java 4, core Java 5 will be displayed, and went back and then comes back advanced. And even thread concept are there. So sometimes core Java c1, core Java 1, advanced Java 2, core Java 3, advanced Java 3, like that it will display. That is okay. All we want is the data here, which data is not which data is dirty, chances of getting dirty, this is the data getting dirty. Okay, so we want to protect data. As of now we haven't protected. Let's see what happens. So thread started core counter 0, advanced Java 0, advanced 2. Where is advanced 1? Advanced Java 0, advanced Java 1 gone, because core Java taken 2, 3, 4, 5, 6, 7, 8, 4 here, thread core ended here. So there is some data getting inconsistent. I'll show you. writing. Small programs requesting is very challenging. Come on. Square sequence. Basically, if you keep trying, right, it's a small program. So basically, don't think like, oh, this guy, why data is not getting dirty. There are chances for data getting dirty. It's not like it's 100%, right? See what I'm trying to say, try to sense it. Okay, the value is 99. Thread 1 came and thread 2 came, right? While it is updating T1, T2, okay, and thread 1 access this one, while it making 100, there is some operations will happen. Before it reaching, if it can able to make 100, then it will get the correct value. Only T2 will get 99 in case T1 to update 99 to 100 takes time, then only you will get the T2 gets 99 where data gets corrupted. Instead of getting 100, it's getting 99. There are very few scenarios. I mean, it will happen in a consistent try, but it doesn't happen every time. Okay, so how do we protect that kind of data? Okay, how do we protect that kind of data, right? So all you need to do is in this program, as this is the dirty data getting dirty concept, right? So let's say you can keep this guy, all these guys into synchronized block. Which guy you need to protect? Whom you are trying to protect? Which object you want to protect is INC. This is the object you want to protect. So by protecting that object, you are protecting the data inside. Let's see what happens now. See, you run 100 times, you will see the same thing. Data never gets corrupted in this case. Data never gets corrupted. Where is this guy? Okay. So that's all about synchronization. So synchronization can be happen in two times, two places. One is by method level, another one is block level. When you call any synchronized method with an object, that object will be locked. Okay, whoever. So if you can make two ways, one is making this block by making this object, or else you can make this method synchronized. Either method level you can do, or you can do it at block level. Okay, when you do it this block level, this object, the object that you pass to the synchronized block, will be locked, and if you do synchronized here, the object that you are creating, that you are calling, will be locked. Okay, don't get confused. Okay, but I request you to go back and listen one more time.